Let us study a new chapter, Metallurgy. What is meant by metallurgy? It is a branch of science concerned with the properties of metals, production of metals, and purification of metals. Long before, that is 4.5 billion years ago, Earth formed. After that, or we can say since then, many processes took place inside the Earth as well as its surroundings. As a result of it, many ores of metals, liquids as well as gases formed inside the Earth. Now we will study the physical properties of metals. So we can say that formation of Earth took place 4.5 billion years ago. Now 1 billion equal to 100 crores. Now 1 crore is equal to 100 lakhs. Now you can imagine that how many years ago Earth formed. Now, what are the physical properties of metals? Now, here we can say that how these metals are available or how it is looking. We can say that how they are. When we look at them, what we feel about the metals. So that is their physical property. Now, first physical property we can say that they are solids. First physical property we can say that they are solids. But here two exceptions are there. That is gallium and mercury. Ga means gallium. Hg means mercury. They both are in liquid form. So we can say that metals are in solid form, but there are two exceptions. That is gallium as well as mercury. They are in liquid state at room temperature. Room temperature means normal temperature. Now, other property we will see, that is metals have luster. Luster means they have shining ability. Again, we can say that freshly cut part of a metal shines. If you are taking a metal piece and if you are cutting it, then where it is cut, that portion will have shining ability. But after long period of time, if you are keeping in the air or in the moisture, again their ability of luster decreases. Decreases means reduces. Now, the third property, that is metals have ductility. What is meant by ductility? Ductility means with the metals we can be able to make long wires. Here I am showing you. This is metallic. Means here we can say it is a wire, but inside this wire, here now insulation is there. But inside this wire, you can find that copper wire. So we can say that copper is a metal. With that we can make a long wire. Other example, this is again a metal. With that means we can be able to elongate metals. So here now we can say that a long piece of metal is this. So the metals have the capacity to become long wires or long rods or long tubes or long what we can say strings. All these things we can say as ductility. That is their ability, or we can say that the metals have the capacity to become long, or elongating power of the metals are known as ductility. Ductility is a property of being elongated. In case of metals, we can make long wires with the help of metals. So that property of the metal is known as ductility. Now the metals which can be able to elongate, those metals we are calling as ductile metals. Now similarly, one more property showing by the metal, that is known as malleability. What is meant by malleability? Maybe malleability means we can hit on the metals, as a result of it metals flattens. Example I am showing you. Here you see, this is iron. On that hitting, it became a flat piece. Similarly, we can say this is now stainless steel. It is an alloy. Even then we can say that alloy is a speciality, mixture of metals or mixture of metals as well as non-metals. So it is a stainless steel, in that a metals mixture as well as a bit of carbon also will be there. We can say that non-metal also present. So on that hitting such a flat piece we can make it. So the ability of metals to get flattened, that is known as malleability. Now the metals which has the capacity to become flat after hitting on it, to them we can call as malleable metals. Now we are going to study the other property. Metals are hard. Metals are hard. So there are, means when we study about metals, in our mind it is very hard. Again I can show you, it is very hard metal. But there are exceptions. We can say that sodium, then potassium, even we can say that lithium, that is lithium, sodium, potassium, they are not hard, they are soft. We can say that these metals are hard, but exception I can say, these are the examples of soft. They are soft metals, not hard. They are soft metals. So normally metals are hard, but here three examples are there. Lithium, sodium, potassium, they are soft metals. Now we will study the other point. They are having high melting point as well as boiling point. Metals are having high melting as well as boiling point. But again, we can say that exceptions are there. That is sodium, potassium. That means alkali metals we can say. Gallium as well as mercury. They are having, we can say that, low melting as well as boiling point. We can say that here lithium, sodium, potassium, these are all alkali metals. Along with that, gallium as well as mercury, they are having very low melting as well as boiling point. Now here, metal, one example I am saying you, that is tungsten metal. Tungsten metal, which is having very high melting point as well as boiling point. Very high melting as well as boiling point. Its melting point is equal to, melting point of tungsten is equal to 3422 degree Celsius. Boiling point is not knowing, but its melting point of tungsten is 3422 degree Celsius. So you can imagine how much will be its boiling point. It will be very high. Now other property we can say that metals are having the capacity of, or metals are sonorous, I can say. Metals are sonorous. What is the meaning of sonorous? Sonorous means if two metals hit with each other, if they struck, hit means a struck, they produce a sound. So we can say that metals struck, they produce a sound. So when we give a chance of hitting two metals, if they make sound, we can say that they are sonorous metals. Now the property of making sound when struck, that is known as sonority. Sonority. So we know the things, we can say any metallic things, if it is falling on the floor, they make a sound. So we can say that in case of bell metals, such and such metals are making very loud, very loud sound. As a result of it, we can say that far away people also can be able to hear the sound of it. So the metals, when we struck on it, if they produce the sound, then we can say that that property of the metal is known as sonority. Again, the metals which are having the capacity to produce the sound when struck, then we can say that is those metals we can say as sonorous metals. The property of making sound, that is known as sonority. Now we will study the physical properties of the non-metals. Before that, once again we will have a quick revision of physical properties of metals. We can say that metals are available in solid state, but there is two exceptions, that is gallium as well as mercury. They are available in liquid state at room temperature. Second thing, they are having luster, that means they are having the shining ability. If we are cutting metals, then it's a fresh surface is having the capacity to shine, but when we keep them long time in the air or in the moisture, then its luster ability or shining ability slow by slow decreases. Other thing we are studying is what is ductility. Metals are having the capacity to form long wires by hitting on it or with the help of stretch. It has the, when we melt them and if we elongate them, it can become a long wire or long string we can say, or long rod we can say. Next one, what is malleability? Metals are having the capacity to become flat surface when we hit on it. Other thing, metals are very hard substance, but there is some exception, that is lithium, sodium and potassium. They are not hard. Even with the help of knife we can cut them into two pieces. Other thing, metals are having high melting as well as boiling point, but at the same time we can say alkali metals, then gallium as well as mercury, they are having low melting as well as boiling point. Now tungsten metal, which is used in the electric bulbs. So we can say the filament of the electric bulb. This is the electric bulb. It's inside you might be seen filament, like that way filament you might be seen. This filament of the electric bulb is made with the help of tungsten wire we can say. This filament that is made with the help of tungsten filament. Now we can say its melting point is equal to 3422 degree Celsius. This is its melting point. Boiling point will be very high. So here its melting point itself is so high, then you can imagine what will be or how much can be its boiling point. After that we are studying about metals are having the property of sonority. Sonority means when they struck, they produce the sound. So the metals which are having the capacity to produce sound when hit on each other or when struck somewhere. So we can say that those metals we can call as sonorous metals. Now we will come to the physical properties of non-metals. Physical properties of non-metals. Now, non-metals are available in solid as well as gaseous form. So, we can say that non-metals are available in solid as well as in the gaseous form. So, they are solids as well as gases. But there is one exception. We can say that bromine is a non-metal. Even then, it is available in the liquid form. So, we can say that non-metals are in solid as well as gaseous state. But there is one exception, that is bromine, which is available in the liquid state or liquid form. Now, other property, we can say that they are not hard. They are not hard substance. Next one we can say, but here one exception again we can say, that is diamond. So here we can say that now in case of non-metals, they are not hard ones. At the same time, there is one non-metal, that is diamond. Its speciality, it is the allotrope. It is the allotrope of carbon. Again, we can say that it has such a speciality. We can say that this diamond is a non-metal. Again, we can say it has such a speciality. It is the hardest non-natural substance. Hardest non-natural substance. We normally studied that non-metals are not having any hardness, but even after being a non-metal, diamond, that is the allotrope of carbon, this diamond is the hardest non-natural substance. In the nature, which all substances are there? In comparison with all substances, diamond is the hardest substance. Now, other property we will study, that is, it has, that means the non-metals have low melting point as well as boiling point. Now, we can say that non-metals specialty, what is there? They are having low melting as well as boiling point. That is the specialty of non-metals. They are having low melting as well as low boiling point. Now, again we can say that they are, here we can say that they are the bad conductor. This is melting point and boiling point is very low. Again we can say that they are bad conductors of electricity. They are bad conductors of electricity. In case of metals, they are good conductors of electricity as well as heat. Here we can say that they are bad conductors of heat as well as electricity. So we can say that metals are good conductors of heat and electricity, but here non-metals are bad conductors of heat and electricity. But here one exception is there. In case of graphite, we can say graphite, we can say that it is the, again graphite is the allotrope of carbon. Allotrope of carbon. Again, one more property, what is there? It is, this graphite is a good conductor of heat and electricity. Good conductor of heat and electricity. So here we can say that non-metals are bad conductors of heat and electricity, but their exception is there. What is that? Graphite. It is an allotrope of carbon. At the same time, it is a good conductor of heat as well as electricity. One more thing. Here we can say that they do not have luster. They do not. That means the non-metals do not have luster. Again, there is one exception, that is iodine. Iodine. It is a non-metal. Even then, it has luster. Luster means a shining ability. All non-metals are having no capacity to shine, or they do not have luster. Luster means they do not have, luster means shining ability. But non-metals do not have shining ability. But here one exception is there, iodine. Even after being a non-metal, it shines. Now, these are the different properties of non-metals. First property, what is there? They are available in solid as well as in gaseous state. But there is one exception, bromine, that is available in liquid state. Second thing, non-metals are not hard, but there is one exception, that is diamond. Diamond is the non-hardest natural substance. It is a non-metal. Again, one more thing I am saying you, here allotrope word came. Here again allotrope word came. What is meant by allotrope? What is the meaning of allotrope? Allotrope means is one element. We can say carbon. But it is available in different forms. We can say carbon in the form of coal, in the form of charcoal, in the form of diamond, in the form of, we can say, graphite, etc. So one element that is available in different forms. Similarly, sulfur also available in different forms. So we can say that allotrope of sulfur, allotrope of carbon. So both of them are sulfur as well as carbon. Both of them are non-metals. Even then they are available, but they are having such a speciality. We can say carbon as well as sulfur, both of them are non-metals. But these two non-metals are having the capacity to occur in different forms. So we are saying that allotrope of carbon or allotrope of sulfur, if they are in such forms. We can say here now two examples we study, that is first thing about diamond. It is the allotrope of carbon. Carbon, normally carbon has black color, but diamond is having such a beautiful color, such a pretty color. But even though that is a form of carbon, so we are saying it as allotrope. This diamond is the allotrope of carbon. Other example, graphite. Graphite pencils, inside the pencil graphite is present. The what we can say, with what part we are writing. So that part or central part of the pencil, we can say that this pencil, it's a central part that is made, the writing part of the pencil, that is made with the help of graphite. Again, we can say that it is having the capacity to pass heat as well as electricity through it. Plus, we can say that graphite is an allotrope of carbon. Then other thing, non-metals having no capacity to shine, but there is one exception. We can say that is iodine. It is a non-metal. Even then it is having the capacity to shine. Now we will study chemical properties of metals. Metals are reactive elements. They have the capacity to lose electrons easily. As a result of it, they are becoming electropositive ions. So here we can call all metals are electropositive. So why we are calling metals as electropositive? Because metals are having the capacity to lose electrons from their outermost orbit. So we are calling them as electropositive elements. Once they lose their outermost electrons, they will become electropositive ions. Again we can say most of the metals are highly reactive. Now we are going to study about the reaction of metals with oxygen. With the help of two examples we will study, that is sodium, reaction of sodium with oxygen and reaction of magnesium with oxygen, and their oxides reaction with water. That means the sodium oxide reacts with water, which compound is forming, and magnesium oxide reacts with water, which compound is forming. That also we are going to study. Here now, sodium, if we are keeping outside, specialty is there, if we keep sodium outside, immediately it catches fire at room temperature. So we have to take so much precaution, but once it get a chance to be in the air, immediately it reacts with the oxygen. That means it catches fire. As a result of it, we can say that sodium reacts with the oxygen, sodium oxide will form, Na2O. We can say oxygen's valency is 2, I written here, sodium its valency is 1. So here we can say that when sodium reacts with the oxygen, or when sodium burns in oxygen, we can say, or reacts with the oxygen means of course it burns, it reacts with the oxygen. So when sodium burns, that means it reacts with oxygen. Any object we can say, paper if it burns, that means it reacts with oxygen. Wood burns, we can say it reacts with the oxygen. Similarly, oxygen, here sodium burns, that means the sodium reacts with the oxygen. As a result of it, sodium oxide is forming. Now, immediately, as and when we write the equation, we need to balance it. That means reactant side as well as product side, whether equal number of elements are equal number of atoms of the elements are present or not, that we have to see. Here now sodium how many? Only 1. But here how many sodium? 2 are there. So I am writing 2. This 2, when we are adding any number, that should be at the left hand side, not to right below. Now 2 sodium, I written here 2 sodium. Now oxygen here how many? 2. But here how many oxygen? Only 1 is there. So I am writing here now 2. Here 2 I written. So we can say that 2 oxygen. At the same time here also 2 oxygen. But the problem became here now sodium's number increased. So here now we have to multiply. That means the 2 2s are 4. So here I written only 2. Now I am removing this. I am writing here 4. So we can say that now the equation is balanced. So first we have to write the equation. Afterwards we have to see that whether it is in balanced condition or not. If it is not in balanced condition, we need to balance it. So here we can say now, here 4 sodium, here again 4 sodium. Oxygen here 2, here again oxygen 2. Now we can say that when sodium oxide, if we are putting in the water, some sodium oxide if we are putting in the water, we can say it is a metallic oxide. Sodium is a metal, it's means compound with oxygen. So we can say that it is a metallic oxide. Sodium oxide is a metallic oxide. Now when we add it or when we put it in the water, immediately it dissolves in the water. At the same time we can say that there occurs a chemical reaction. As a result of it, sodium hydroxide is forming. We'll see now. Sodium hydroxide, Na2O. Sodium hydroxide, sodium oxide. Its formula Na2O. That dissolves in water. We people are putting sodium oxide inside the water. As a result of it, you can find that there will be the formation of sodium hydroxide. Sodium hydroxide. We can read it as sodium hydroxide. Now again we can say NaOH. So here sodium's valency 1, even OH ion, its valency also 1. Because of that we written NaOH. Now we need to balance it. Here how many sodium? 2. So I am writing here 2. Because here before 1 was there, so I added 2. Now oxygen here how many? 1. Here again 1. So oxygen 2. 1 plus 1, 2. This before the arrow mark, how many elements are there? How many atoms are there? Similar ones all you have to add it. So here now 2 oxygen. So here now again 2 oxygen. This 2 is common for all the atoms of the elements. Now here 2 oxygen, so that is balanced. Hydrogen how many? Here 2. Here again hydrogen 2. So equation balanced. So here we can say that the oxide of a metal, if it dissolves in the water, we can say that there will be the formation of alkali. So here we can say sodium hydroxide is an example of alkali. Why it is an alkali? Because this oxide, the oxide of the sodium can dissolve in the water. As a result of it, it reacts with the water. Then it forms sodium hydroxide. Now we can say sodium hydroxide is an example of alkali. Now what is the specialty of sodium? If it is keeping open in the room temperature, immediately it catches fire. Because of that, we are keeping sodium metal inside kerosene. We have to keep kerosene in, we have to keep sodium metal inside the kerosene. Why? Because inside the kerosene, suppose if you are taking kerosene in a beaker, just imagine this is kerosene. Now, in that, if you are putting a piece of sodium, Na means sodium, immediately it sinks inside. Sinks means sodium metal go inside the kerosene. Why? Because in comparison, kerosene, its density less. Density of kerosene is less. Already I written here kerosene, so its density is less. But at the same time sodium, its density is more. As a result of it, sodium sinks in kerosene. Second thing, once it is sink inside the kerosene, that sodium does not get any reaction or any touch with the oxygen. One thing. Second thing, it does not react. That means sodium does not react with the kerosene. Two specialities are there. One speciality, sodium does not react with the kerosene. First speciality. Second thing, sodium sinks in kerosene. So because of that, this sodium cannot be in touch with the oxygen. As a result of it, there won't have any fire. But at the same time, if you are keeping sodium in the air at room temperature itself, it catches fire and produce sodium oxide. This sodium oxide is having the capacity to dissolve as well as react with water. As a result of it, it produces or it forms sodium hydroxide. Sodium hydroxide is an alkali. Now, other example, we are going to study about magnesium. Magnesium can react with oxygen when it burns. That means if you are taking a ribbon off or a piece of, I am saying you, a thin piece of magnesium if you are taking and we burn it, then it reacts with the oxygen. As a result of it, it produces magnesium oxide. We can say valency of oxygen is 2, valency of magnesium also 2. So 2 and 2 cancelled. Because of that, the formula of magnesium oxide is MgO. MgO. M should be capital, G should be small. This is for magnesium, then oxygen. Now we have to see that whether it is, once we write the equation, we have to balance and see. Here now magnesium 1, here again magnesium 1, oxygen 2, but here only 1 is there. So left hand side I am writing 2. So we can say that 2 MgO. Now 2 MgO. Let us balance and see once again. Here Mg how many, magnesium how many, 1, but here Mg how many, 2. So I am writing here now 2. So we can say that now 2 Mg. Here also 2 Mg, magnesium balanced. Oxygen here 2, here again oxygen 2. So equation balanced. Now we will study here magnesium oxide can react with, or it can dissolve in water, as well as it can react with water. As a result of it, magnesium hydroxide is forming. Again it is an alkali. So we can say that if the oxide of a metal can dissolve in water, then we can say that that is an alkali. So here now we can say magnesium oxide, here sodium oxide, both of them can dissolve in water. So we can call them as they are alkalis. So we'll see now magnesium oxide can dissolve in water. Once it dissolves means it can react with the water. As a result of it, it produces magnesium hydroxide, MgOH twice. Now we will balance and see. Magnesium here 1, here magnesium 1. Oxygen here 1 and here 1. So 2 oxygen, here we can say that 2 oxygen. This bracket is there, it is common for oxygen as well as hydrogen. So from this we can understand that oxygen 2, hydrogen 2. So here oxygen 2, hydrogen how many? 2, hydrogen 2. So here we can say that no need of balancing now. Directly we written here magnesium hydroxide. Again we can say magnesium, its valency 2, that I written here. Then OH ion, its valency is 1. So I didn't write anything. If there is 1 valency, no need of showing. If 2 valency, then only we have to show. That is also we can see both the side of 2 valencies there, no need of showing. Here now 1 is having, this is having valency 2. So opposite side we have to put it. Now here it's a valency 1, that we have to put it. So here now whenever we people are writing the valency of, suppose here now in case of magnesium oxide, here 2 elements are there. Magnesium its valency 2. Oxygen its valency again 2. So 2 and 2 means we will cancel and go. So no need of writing. So we can say that alternate place their valency we have to put it. So here now the reaction of metals with the oxygen we studied. First example, that is sodium, its a reaction. Second thing, the reaction of magnesium. Only 2 examples we have to study. So here we have to see that sodium reacts with the oxygen. Sodium oxide is forming. That sodium oxide is having the capacity to dissolve in water, as well as it is having the capacity to produce sodium hydroxide when it reacts. Once it is dissolving means it can react with water. As a result of it, a different compound is forming, that is sodium hydroxide. Other thing, magnesium, that we have to burn that. Means if we are keeping open, it won't catch fire. In case of sodium, just we keep outside, it catches fire. But at the same time, in case of magnesium, if we keep at room temperature, it does not catch fire. Then what we have to do? We have to burn it. Once we burn, that particular time it catches fire. Once we burn means it reacts with the oxygen. Then it produces magnesium oxide. This magnesium oxide also having the capacity to dissolve in water. Once it dissolves, then that means that during dissolving time itself we can say this water reacts with the magnesium, or water reacts with the magnesium. Here water reacts with the magnesium oxide, or we can say water reacts with the sodium oxide. When it reacts with the sodium oxide, it produces sodium hydroxide. When it reacts with the, when magnesium oxide reacts with the water, we can say that it produces magnesium hydroxide. Now we will study the reaction of metals with water. Here there are few examples I written: sodium, potassium, calcium, aluminium, iron as well as zinc. Now how they react with water we'll see. Here sodium reacts with water, potassium reacts with water. Both of them reacts vigorously with water. Vigorously means highly reactive with water. As a result of it, they both produces their hydroxides. NaOH, along with that hydrogen gas, along with that heat energy they produce. Similarly, this thing also, sodium produce heat energy. Similarly, potassium also produce potassium hydroxide KOH. Along with that hydrogen gas and heat energy also produces. So we can say that these two metals, sodium metal as well as potassium metal, reacts in the same way. As a result of it, we can say that both of them produces heat energy. Compounds also similar, sodium hydroxide plus hydrogen gas, here potassium hydroxide plus hydrogen gas, but one speciality, both of them vigorously reacting with water. As a result of it, both of them produces heat energy. Here sodium hydroxide plus hydrogen gas, along with that we can say heat energy also producing. Here this sodium as well as potassium highly reactive with water. Now here it's a balancing work we will do after solving all this. Now you see calcium. Calcium reacts slowly with water. As a result of it, calcium hydroxide CaOH twice, along with that hydrogen gas is forming, but no heat energy. Calcium slowly, less vigorous condition, slowly reacts with water. As a result of it, calcium hydroxide as well as hydrogen gas is forming, but no heat energy. Now here aluminium, then iron as well as zinc, they cannot react with water. Which water? Cold water as well as, they cannot react with the cold water as well as hot water. But at the same time, these three elements can react with steam. So here means H2O, here it is representing for steam. We can say water vapor. With the help of water vapor they can react, but with the help of cold water as well as hot water they cannot react. As a result of it, all the three produces their oxides. Aluminium reacts with the steam and produce aluminium oxide, along with that hydrogen gas. Iron react with the water, it produces ferric oxide, Fe3O4. Fe3O4 we can read as ferroso, 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 ferric, Ferric, ferric oxide. Ferroso-ferric oxide, Fe3O4. Along with that, hydrogen gas is producing. Similarly, zinc reacts with the steam, not with cold water, not with the hot water. It reacts with the steam and produce zinc oxide, along with that hydrogen gas. So now we studied reaction of metals with water. Here two examples of metals, here one example of metal, here three examples of metals. Here sodium as well as potassium vigorously reacts with water. Calcium less vigorously react with water. Aluminium, iron and zinc, they have no reaction with the cold water as well as hot water. They react only with the steam, that means water vapor. Here you can find that the difference, here sodium hydroxide, potassium hydroxide, calcium hydroxide is forming. But here you can find that no hydroxide formation, only they form their own oxides. Now balancing, we'll see how we can be able to balance it. Here sodium 1, here sodium 1, balance. Hydrogen here 2, but here hydrogen 3 is there. So what I am doing, here 1 is there, that I am making as a 2. Now here hydrogen's number I increased. So 2 became, here now 2 became, so 4 hydrogen is there. Now at the same time one more thing. So here I am making now 2 hydrogen. So I am making here now 2 more. So total will be 4 hydrogen. Here 2 2s are 4. Here 2 hydrogen plus 2 hydrogen, 4 hydrogen. Now we will see the other element, that is oxygen. Here how many oxygen? 2 oxygen. Here how many oxygen? 2 oxygen. So that is balanced. Now sodium. Here 2 sodium, but here only 1 sodium. So I am making here 2. Now once again we will check it. Here total 2 hydrogen plus 2 hydrogen, 4 hydrogen. Here 2 2s are 4 hydrogen. Here 2 oxygen, here 2 oxygen. Sodium here 2, here also 2 sodium. So this equation is balanced. Now we will see here. Here potassium 1, here also 1. Hydrogen here 2, here hydrogen 2 plus 1, 3 is there. So I am making here again 2 because single is there. So I made it as double. Now you see here potassium 2. So I am making here now potassium 2. Hydrogen 2. Here hydrogen 2 plus 2. 4 is there. So I am putting here 2. Now oxygen. Here 2 oxygen. Here also 2 oxygen. So equation is balanced. Here 2 potassium. Here also 2 potassium. 2 2s are 4 hydrogen. Here 2 plus 2 4 hydrogen. Here 2 oxygen. Here also 2 oxygen. Now here calcium here 1, here also 1. Hydrogen here 2. Here hydrogen 2 plus 2 4. So here now what I can do, here 2 plus 2 is a 4 is there. So I am making here now 2. So hydrogen now 4 became. Calcium here 1, here also calcium 1. Hydrogen 4, hydrogen 4. Now we will see oxygen how many, here 2. Here also oxygen 2, equation balanced. Now here we will do. Aluminium here 1, here aluminium 2. So I am putting here now 2. Then hydrogen here 2, hydrogen here 2. Oxygen here 1, oxygen here 3. So I am putting here now 3. So oxygen now 3, here oxygen 3. Hydrogen here now 3 2s are 6. Here only 2 is there. So I have to make it as 3. So 3 2s are 6. Here also 3 2s are 6. Equation balanced. That means we have to make equal number of each and every atoms of the element in both the sides. Here now aluminium 2. Here also it should be 2. Here hydrogen 6. Here also should be 6. Oxygen here 3. Here also should be 3. Now here iron 1 is there. But here how many iron? 3. So I am putting here now 3. Here hydrogen how many? 2. Here how many? 2. Here how many oxygen? 1. But here how many oxygen? 4. So I am putting here now 4. Oxygen number 4 became. Along with that hydrogen's number increased. Hydrogen 4 2s are 8 became. But here only 2 is there. So I have to make it as now 8. How I can make it? Just I have to multiply with the 2. So we can say that 4 2s with the 4. So 4 2s are 8. Here again with the 4 I written. So with the 4 we have to multiply. 4 2s are 8. So once again we will see 3 iron. Here also 3 iron. Here hydrogen 4 2s are 8. Here also 4 2s are 8. Oxygen 4. Here also oxygen 4. So we can say equation balanced. Next one, zinc plus water. Zinc plus steam. Here Zn 1. Here also Zn 1. Here H2. Hydrogen 2. Here also hydrogen 2. Oxygen 1. Oxygen 1. So we can say that this equation already in the balanced condition. Now we will see here, in case of calcium. Calcium reacts with water. That reaction is very slow, we had already studied. As a result of the formation of calcium hydroxide, along with the calcium hydroxide, hydrogen gas also forming. That hydrogen gas, without escaping into the air, it collects on the calcium metal. As a result of it, the calcium metal floats on the water. We'll see here now. This is the calcium. Just imagine calcium metal, on that bubbles of hydrogen gas will collect. As a result of it, this calcium metal will floats on the water. Now let us see here once again a quick revision of it. Sodium as well as potassium reacts with water. The reaction is very quick, very vigorous, highly reactive. We can say that sodium as well as potassium reacts with water very quickly, very fast way, very vigorous reaction is taking place. As a result of it, we can say that sodium hydroxide, hydrogen gas as well as water heat. Here potassium hydroxide, hydrogen gas as well as heat producing. The hydrogen gas which is producing, that liberates or that evolves into the atmosphere. Now here calcium as well as water reacts slowly. We can say less vigorous reaction. As a result of it, hydrogen gas is coming out. That hydrogen gas just collects on the calcium metal. As a result of it, calcium metal floats on the water. Here when we see aluminium, zinc as well as iron, these three metals cannot react with cold water as well as hot water, but they react with steam. As a result of it, we can say that there will be the formation of their oxides here. Along with that, hydrogen gas is evolving out.